Hi guys, welcome to another video from the GMAT guy. This video is about, we're trying to solve a problem here, data sufficiency question. It's not a concept video, but we're just looking at an example question. Looks pretty standard, but let's go for it. So a data sufficiency question this is. A set contains the following 5 numbers: a square, a to the power 5, a over 2, a over 5. Look at these 5 numbers. You've got powers. A is like the reference point, which is like the center, and then you've got a square, a to the power 5, which usually when you think of intuitively, just look at integers. Like if you take the integer 2 or 3, a square and a to the power 5 will be bigger, will amplify, while the fraction a over 2 or a over 5 will generally be smaller than a. So okay, that is kind of the idea that we can use as a starting point. The question is the range of the set equal to a square minus a to the power 5? What they're trying to say, so first thing what I'll do is, when will the range be a square minus a5? The range will be a square minus a5 when a square is the biggest and a to the power 5 is smallest. Okay, now when can that happen? Right, now I'll try to think of different values for a. Now for this, on the number line, what I'll do is I'll look at 4 different segments. This is 1, 0, negative 1. So first we'll look at segment 1, and we have segment 2, then we have segment 3, and then we have segment 4. If I take any number above 1, a square will be, it'll be bigger, yes, but a to the power 5 will be even bigger, right? Take a look at the example of 2. 2 to the power 5 is bigger than 2 square. So first, to make this, the range to be this, to fulfill these 2 conditions, that a square should be the biggest and a to the power 5 should be the smallest, we cannot take numbers in the zone 1. Zone 2, when you look at fractions, positive fractions, then you have something like example half, right? A to the power 5, well, this stands a good chance. If I just take this example and plug it into the 5 numbers, I know that a to the power 5 will be the smallest in these 5. A over 2 will be 1 over 4, a over 5 will be 1 over 10, a to the power 5 will be 1 over 32. So yes, here, and a square, will it be the biggest? So will a square be the biggest? In this case, in one case, yes. In this particular example, yes. Actually, no. A is bigger. So no. Zone 2 does not fit our requirement as well. Here what happens is that yes, a to the power 5, a to the power 5 is the smallest, but a square is not the biggest. A is bigger than a square when you take a look at numbers from 0 to 1. As soon as you square it, the fraction becomes smaller. Okay, zone 3, let's take a look at that. Let's take a look at an example of negative half. So negative half makes a square. So if I take an example of negative half, a to the power 2 and a to the power 5 will all 3 be negative. A to the power 5 will also be negative, but a to the power 5 would be negative 1 over 32, which is bigger than negative half. So it's not the smallest, so this is not the zone. So we know that the numbers have to be in zone 4. Okay, an example can be negative 2. If you have negative 2, a square is 4, a to the power 5 is negative 32. So this looks like the right thing, exactly what we wanted. Zone 4 is where we will get the range a square minus a to the power 5. Okay, so the question, I can rephrase the question as, is a less than negative 1? That's the question. Alright, so the question has been rephrased as, is a less than negative 1? If it is, we know it's in zone 4, this will be the range. Okay, so that's how you have to crack the question. This is one strategy. You can rephrase the question by understanding when does that happen. When does that condition get fulfilled? First statement says a is negative. So now it's very easy. A is negative doesn't mean that it's zone 4. It could be zone 3 or 4. So the first statement is insufficient. A to the power 5 is less than a. Okay, interesting. Which of these 4 zones does a to the power 5 be less than a? Well, not in zone 1. I'm going to take a look at the next slide for this. So second statement, a to the power 5 is less than a. Zone 1, I'm going to take an example of a equal to 2. Zone 2, a equal to half. Zone 3, a equal to negative half. And zone 4, a equal to negative 2. Okay. In zone 4, it is less than, a to the power 5 is less than a, we just saw that. In zone 5 you have 32 less than 2, no. Zone 2 you have 1 over 32 less than 1 over 2, yes. And zone 3 you have negative 1 over 32 less than 1 over 2, negative 1 over 2, no. Okay, so zone 2 and zone 4. Second statement implies that a can be in zone 2 or zone 4, so it's insufficient, right? But when you mix the two statements together, 1 and 2 together, we know that the first statement says a is negative. So between zone 2 and zone 4, this is the narrowed down list, the area, the zones where a can be based on statement 2. Statement 1 says that a has to be negative. In zone 2, is it negative? No. So this gets cancelled out. Zone 4, yes. So shortlist. The two statements together help us shortlist, narrow down that a has to be a value from zone 4, which means a is less than negative 1, which is exactly what we were looking for. That means a square will be the biggest out of the 5, and a to the power 5 will be the smallest term out of these 5, and so that's the answer. C. Both statements together are sufficient to narrow down to the answer. Yes, it will be that. Okay, so that's how you do this question. But yeah, if you've got any doubts or anything, just drop me an email and we can discuss this further, or just contact me and we will talk about it in detail. All right, thank you for watching. Bye bye.